Hi everyone, my name is Juan Pablo. Welcome back to a new YouTube video. And in this time we will continue talking about the mapping server. But this time we will talk about the scenario that occurs when, for example, we have a splitted domain into our core network. So for example, if we see the diagram, we saw in the previous video what happened whenever all the network is in the same ISIS domain, right? So we have P1, P2, provider 1 and provider 2, the raw reflector, all of them are in the same ISIS domain. And we, in the previous video of the mapping server, we defined the P1 as a mapping server. So basically this guy was assigning the static labels, right, for the segment routing, the prefix hit basically, right? For the loopback of P1, he was assigning it over the configuration and propagating to the domain, right? But all the routers were in the same ISIS process and the same ISIS domain and area. So meaning that all the routers that were speaking segment routing, specifically this router P2 and provider 2, they were receiving that over ISIS. The propagation was done over ISIS. Now, we will talk and we will see now what happens if we have a separate domains of ISIS. Let's say by one side we have ISIS and segment routing, and by the other side we have OSPF and LDP, okay? So we will configure yet provider 1 as a mapping server, but the thing here is that if we configure over provider 1 the prefix seed for reaching out the loopback 0 of P1, as we were doing normally as a mapping server, and we propagate this over ISIS only, over the SR domain only, what will happen is that provider 1 will propagate the prefix seed of provider H1. And here I am not going into the details how the mapping server works and why we need to propagate the loopbacks. If you want to go and understand the theory behind, please go over the previous video. There I explain why we need a mapping server from scratch in a short time, and probably this video will make sense. Okay, so in this case, in this scenario, when we have OSPF in one side and we have ISIS in the other side, and segment routing and LDP, what will happen if we continue and configure mapping server as normal? Provider 1 will propagate the prefix seed to the devices in the segment routing domain in the ISIS process, okay? So meaning that provider H2 and provider 2 will receive the prefix seed for the loopback 0 of P1, that the prefix seed is 16,001. We will keep configuring the same value, okay? So both of them will receive and there will not be a problem, right? Provider H2, sorry, will have 16,001 for reaching out the loopback 0 of P1, and this is supposed to solve our issues with the LDP and segment routing domain in the provider network. That's totally fine. We will still have this here. But the big problem here is that whenever, let's say a customer 2, right, wants to reach customer H1, he sent a traffic with the destination of customer H1, provider H2, of course, needs to know what is the next hop, what is the PE device that he needs to reach in order to reach out the C1. Obviously, the next hop is the loopback 0 of P1, the loopback 1111. So here it has the 1111/32, and P2 has a 2222/32. So provider H2 knows that the next hop for reaching out that service is P1. What is the label, the transport label that P2 needs for reach out provider H1? He needs the 16,001. Do I have it? Yes, I have it because the mapping server sent to me. Now, provider H1 then say, okay, so I need to reach out to provider H1, and I am sending the label to my next hop, which in this case, let's say is provider 1, and I will send the label 16,001. Now, provider 1 received the label 16,001, and he needs to switch that label 16,001 over the LDP label, right? Provider 1 knows what is the LDP label because of the OSPF domain and LDP in this site. So he knows, and let's say that the label is 24,002, right? He knows that label. But the fact is that provider 1 will not be able to do that switchover and will not be able to put in the LFIP. If I receive 16,001, I need to switch over to 24,002 because the OSPF domain doesn't know what is the label that has been propagated over the ISIS domain to reach out to the loopback 0 of P1. So the OSPF domain doesn't know what is, again, the label that was assigned in segment routing to reach out the loopback of P1. And if the OSPF domain doesn't know, then it cannot fit the LFIP with that label. Because provider 1, he knows that to reach out P1, he needs to use the loopback 24,001 by LDP. He knows that he needs to push that label over that. But he doesn't know what label to expect to do this traffic switchover. That label has to come from segment routing, from the propagation of the mapping server. But there is no mapping server configuration over OSPF. We only did mapping server configuration, and specifically the command of advertise segment routing mapping segment routing prefix it advertise local. This command, segment routing prefix it advertise local. We didn't do this command in the process of OSPF. We only did in the process of ISIS. So also OSPF needs to know what is the label that is being used in segment routing in order to fit this part of the LFIP. Okay, because in this case the LFIP is being fed by OSPF, because OSPF is the one that knows the label to reach out to the loopback of P1. So OSPF support, the RIP of OSPF support to fit the LFIP, but the RIP of OSPF and OSPF itself doesn't know what is the label to expect. Okay, I hope that this has been clear. So if not, please repeat the video because it might be a little confusing, but the main thing here is that we need to tell OSPF what is the prefix seat that was assigned to P1, because only ISIS knows about it, because we configure this command, segment routing prefix it advertise local. Okay, so in order to make this to work and the traffic not to be black holed here because he doesn't know what label to expect, we need to go to OSPF and configure first segment routing, because of course OSPF, or at least this router, the mapping server, needs to speak and needs to have the opaque LSAs enabled for support segment routing. This needs to be done because how I will propagate a label from the mapping server to a process that is not enabled yet. So I need to enable first segment routing, in this case, under OSPF. And the second, I need to configure the command that we use for advertise the labels on the mapping server. Okay, so I have to do those two tasks in the devices that are transit for the communication between both domains. Okay, so in this case, the transit device will be also the mapping server and will be also the forwarding of the traffic, and will also need to have this command and this command enabled for being able to fit the LFIP. And that's it. Let me show you in the lab how this is happening. So for example, now we have this scenario exactly the same. We have OSPF in this area, in this left area, and ISIS with segment routing in this right side area. And we see the label 16,001 in P2. And then we will see what's going on the provider in the middle. So let's go to P1, to provider, sorry, P2. So if we type show sef 1111, we see that the label is yet there, 16,001. So doesn't matter if we have separate process, the segment routing domain will always get to know what is the label to reach out the LDP domains. But if we go over the provider one, that is a transit provider between both domains, and is also the mapping server in this case, if we type show MPLS forwarding, better, we see that we don't have the 16,001 label here. Okay, because here we configure under the mapping server that we will use the index 1. Remember that the label in segment routing is built by the segment routing global block 16,000 plus 1. So 16,001 will be for an identification in the segment routing domain to reach out the P1. We propagate this under ISIS, as we did here with this command, advertise local, but we didn't propagate under OSPF. There is no this command and there is no segment routing. So this means that OSPF, since OSPF built the LFIP for the LDP domain, he doesn't know what is a label in segment routing assigned for the loopback 0 of P1. So we need to let OSPF know what is a label in order to fit this part that is missing. Okay? And in order to do that, I need to go to provider 1 or to the mapping server or to the device, sorry, that is in the middle of both of them, and enable segment routing, of course, and enable segment routing prefix seed map advertise local. I need to enable both of these commands, commit, and then show MPLS forwarding. 16,001 is there, the label is there, and now if I try a traffic again from C2 to C1, and I leave it completely, and then I go to provider 1 and I remove the configuration that I just applied, both configurations in OSPF. So configuration rollback, I think it's rollback configuration plus 1. I remove both of those commands under OSPF, and let's see what's going on here. So the traffic is being dropped because provider 1 doesn't have the label 16,001. If I reapply again, so go to OSPF, segment routing MPLS, segment routing MPLS, segment routing prefix seed advertise local, then the traffic will keep it forwarding up and running. So that was all about this interesting feature or workaround. Let's say whenever you have two domains, whenever we have one domain, is kind of expected that the segment routing labels will be propagated to all the routers, including the router in the middle. But when we have two networks in different domains, then we need to do this configuration to make it work and make the other LDP, IGP that the IGP protocol is working in the LDP domain to be aware about what labels has been using in segment routing as well. So that was for this video today. So I hope that you have fun and you have learned something. So thank you very much for watching and see you in the next one. Ciao.